Hello class, this is section 5.3, double angle formulas. So here's the first double angle formula, which is sine of 2a is equal to 2 sine a cosine a. So let's use that formula to solve or find sine of 2a. So if we use the formula, we know that sine of 2a is equal to 2 times sine of a, cosine of a. They already give us what sine of a is, it's 3/5. So now we have to figure out what cosine of a is. The way I like to do this is I just draw a coordinate plane, and they're telling us that the angle is in quadrant 2. So if you draw your angle in quadrant 2, any triangle will do. And we know that opposite is 3, opposite over hypotenuse, so 3/5. And so this is a 3, 4, 5 triangle, but this is negative because you're in quadrant 2. So quadrant 2 is negative, positive. That's why this is negative. All right, so now we know what cosine of a is. It's adjacent over hypotenuse. So that pretty much does it. 2 times sine of a, which is 3/5, times cosine of a, which is negative 4/5. So our final answer will be negative 24/25. All right, here are the cosine double angle formulas. There's 3 versions of them, the first, second, and the third. And it just depends on the problem which one, it just depends on the problem. The problem will determine which of these 3 we should use. All right, and then the double angle formula for tangent is this. And so for this next example, notice that they want us to simplify this. It looks very familiar. It looks just like this, where a is 15 degrees. And so we can write this as tangent of 2 times a. Tangent of 2 times a, where a is 15. So tangent of 2 times 15 degrees, which is tangent of 30 degrees. All right, and so if you look at your unit circle, that's going to be tangent. The y coordinate for 30 degrees is 1/2 divided by radical 3/2, multiplied by the reciprocal. You get 1 over radical 3, which is radical 3/3, if you rationalize the denominator. All right, let's look at the homework. So for this one, this looks very familiar. That looks just like our cosine double angle formula. And it looks like the second version, this one here. So let's go back. 2 cosine a minus 1, 2 cosine a minus 1. So let's factor out a 4. And if you factor out a 4, you get cosine squared minus 1. So, you'll get 2 cosine squared x minus 1. And that is a double angle formula, so that's 4 times. This part in parentheses is your cosine double angle formula, cosine of 2x. All right, so that's just going to be 4 cosine of 2x. All right, so we know the amplitude. We know cosine starts at the amplitude, which is 4, so it can't be this one. And it can't be that one. It's got to be one of these 2. And because the period is going to be 2 pi over b, the period is 2 pi over b, and b is 2. That means the period is pi. This one has a period of 2 pi, so it can't be that one. This one has a period of pi, so it's got to be this one. All right, this one, they want us to find tangent of 2a. Well, let's go back to our formula. Here's a tangent double angle formula, 2 tan 1 minus tan squared. 2 tan over 1 minus tan squared. All right, and they tell you what tangent of a is. It's radical 3. So this is going to become 2 times radical 3 over 1 minus radical 3 squared. And that would become 2 radical 3 over 1 minus 3, which is negative 2. So that's going to be 2 rad 3 over negative 2. So our final answer is going to be negative radical 3. All right, next problem. All right, this one's a little bit more difficult to identify. Let's look for a formula that would work. In this case, I believe this is going to be the formula that's going to work for us. Sine of 2a equals 2 sine a cosine of a. And if you divide both sides by 2, then you'll get this formula. 1/2 sine of 2a is equal to sine of a cosine of a. And a is going to be pi over 12. All right, so if a is equal, let a equal pi over 12, then we have 1/2 sine of 2 times pi over 12 is equal to sine of pi over 12 cosine of pi over 12. This is exactly what we have on the right side, so our solution should be this. So you can simplify this. That becomes 6 pi over 6. And we know that the sine of pi over 6 would be, that's going to be, unit circles, pi over 6 is, the sine is 1/2. So that's going to be 1/2 times 1/2. 1/2 times 1/2, which is 1/4. All right, this one over here, it's an identity we need to prove. So it looks like they expand the left side out. If you FOIL this out, you have to write it twice in FOIL. You're going to get sine squared times 2 sine x minus cosine x plus negative cosine times negative cosine is positive cosine squared. That's just FOILing this out, writing it twice and then multiplying. All right, and then it looks like they grouped this one and this one together. And then they got this part in the back, towards the back. So we want to write sine squared plus cosine squared. And then the final step is identifying this to be equal to 1. It's a Pythagorean identity, so that's going to be 1. And there it is. All right, for this one, it looks like they're working on the left or the right side. And they're using the formula for the double angle, so it's 2 sine cosine. All right, and then for the bottom, they're also using the double angle formula for cosine. Remember, there's 3 versions of it. So let's see which version makes the most sense here. Of these 3, I think it's going to be the first one. Or actually, no, it's going to be this one right here, the third one. 1 minus 2 sine squared. All right, and then let's see what's happening now. And now it looks like they are multiplying. Well, this is just 2 sine cosine. That didn't change. What they changed is the bottom. And now, as you can see, 2's cancel. 1 sine cancels with 1 sine, and you're left with 1 sine in the denominator, and you're left with cosine in the numerator. And then cosine over sine is cotangent. All right, for this one here, it looks like they are splitting up the 3 theta into 2 theta plus 1 theta. 2 theta plus 1 theta is 3 theta. And then they're using the double angle formula, I believe. Let's see if that's the case. Actually, they are going to, oh yeah, they're using the sum formula. The sum formula for sine is this one, the very top one, sine, cosine, cosine, sine, sine, cosine, cosine, sine. So it's going to be sine of the first, cosine of the second. All right, and now it looks like they are going to write the double angle formula for this. The double angle is 2 sine cosine. All right, and then the next step would be to multiply cosine times cosine, which is cosine squared. And then the next step would be to, let's see what they do next. Looks like they factor out a 2 sine. Is that what they do? Sometimes it's harder to follow when they write half of the workout for us. Let's see, this stayed the same. This stayed the same. So the only thing that changed is cosine squared got written as 1 minus sine squared. They just rewrote cosine squared into 1 minus cosine squared. I'm sorry, cosine squared into 1 minus sine squared. And now it looks like they are going to distribute. So the first one is here. The second one should be 2 times sine cubed. 2 sine cubed theta. That does it. And for the last one is going to be, they're going to rewrite this double angle formula as, let's see here, that's going to be 2 sine of 2a cosine of 2a. Oh, I'm sorry, they already have the cosine written for us, so it's just 2a, not cosine of 2a. You have to be careful with that. All right, and then the double angle formula for cosine of 2a can be written as cosine squared minus sine squared a. That's one of the versions.
But Mom, why